the benefit of TypeScript is to just have confidence over, the types we're passing around. I generally prefer types, but some people will get heated with a discussion about which one is better in which situation. So we've got these red squigglies because VS Code has detected that you are typing this object as a custom object type. So if we put these in just like that and then finish off the object, now this is matching the type that we've assigned it. And if we tried to add an extra prop, it's going to yell at us because that does not exist in the type that we gave it. So if I was a developer and this was a big project and someone else had written this function, it's not very clear to me what the contract of this function is. So if we explicitly say derived stats, now when we change it, it's going to complain because the wins is declared here, but we are calling that win count. So if we put that back to wins, now it's going to be happy, and it gives us the assurance that we didn't break something elsewhere within our code base. So in other words, what target represents is the end state of the code that is going to be compiled. So I made a video where I refactored subscribers' code, and we worked on this tic-tac-toe game, and we built this in vanilla JavaScript. It took us quite a while because I went through a lot of different concepts and patterns to build this out, but now it's time to refactor this to TypeScript. And the question is, why am I doing this? What is the point of using TypeScript in the first place? So this video is going to be a refactor where we take a vanilla JavaScript tic-tac-toe game and we refactor it to use TypeScript. And along the way, I'm going to explain and point out why TypeScript is so helpful and why so many employers look for this skill in developers. Let me start by saying that this video is specifically geared for people who either have not used TypeScript and are trying to understand what the hype is about, or are just a beginner developer, you're looking to land a job and you're trying to understand what that path to getting that job looks like. And I can assure you there are many companies out there using TypeScript today. I write it in my day-to-day job, and it's an awesome thing if you learn how to use it correctly. So with that said, we're going to just jump into this video. I recommend that if you want the most out of this video, you should probably watch the original build. So like I said, we refactored some subscriber code and built this tic-tac-toe game, and took several hours. So I know it's a bit of a pain to go rewatch all of that, but this is going to be a much clearer video if you have that background and you understand the steps that we took to get here. At the very, very least, be sure to go to my GitHub repository. I've linked to it in the video description, but let me just show you the one that I'm talking about here. So let's go, nope, that's not the right one. So tic-tac-toe subscriber refactor. At the very, very least, you need to go through and open up this vanilla refactor and then read through all of the code here, okay? And we have a second branch called TypeScript, which this is the final version of the video that I'm doing right now. So we're going to head towards this right here, and we're going to start with the vanilla JavaScript. So without further ado, let's jump in and get this refactored to TypeScript. All right, so the first thing I'm going to do is just copy this entire folder. So let's see, paste. All right, and then we're going to call this a TypeScript, actually let's say live TS refactor. Okay, so here, forget about this for 1 second. We'll get to that. That's very important for this refactor. It was just in my git ignore. So just to overview, we've got an index.html file that's got some styles and it has this script down here that connects to the app, store, and view. So the MVC pattern that we talked about in that prior video, once again linked in the video description. And here's the CSS file, nothing crazy going on here. Like I said, you need to be familiar with this application because I'm not going to explain it in any detail here. So the question is, if you want to move towards a TypeScript code base and you've got a vanilla JS code base to start with, how do you go about migrating it? If you are dealing with a very large vanilla JavaScript code base, this is not the video to teach you how to migrate that. This video is basically going to walk you through the most simple steps, the initial setup of a TypeScript app. So the first thing that we need to do and to understand is that when we're writing TypeScript, we will now need developer dependencies. So talking about like a package.json, if you notice in our original build, we don't have a package.json or node modules or anything like that because we don't need them. We can just write vanilla JavaScript ES6 syntax and run that directly in the browser. So there's no developer dependencies, there's no build steps, transpiling, any of that stuff. So the biggest thing you need to understand to start out is that we need some dependencies, and the dependency we need is TypeScript itself as well as the TypeScript compiler. Now, I'll be honest, I don't set up blank TypeScript projects from scratch every day. It's not a very common thing because once you get your stuff set up, you don't really think about it. So I'm going to imagine that you're starting from scratch trying to figure out how to get this started. And we're going to just use documentation to get ourselves there. So let's go to the TypeScript documentation. This is the first place that you would obviously go to figure this out. So there's a get started, a handbook, and a reference. These are going to come in once you're kind of well into things. The get started is where we want to start. So let's go ahead and look maybe TypeScript tooling in 5 minutes. Looks like a good starting place. So if we look at this page, it's going to tell us how to get started. So we can install TypeScript in two main ways, through npm or yarn or pnpm or whatever we're using, or by installing the Visual Studio plugins. Now I believe this is talking about Visual Studio, the full-on IDE, not necessarily Visual Studio Code. I think there's a big difference between those two. We'll get to that though. And it says you can install it just like this. But what I want to find out, VS Code TypeScript, let's see how it pairs with Visual Studio Code, which is what we are using here. It says, TypeScript is a superset of JavaScript, blah, blah, blah. And it says it comes with the language support, but it does not come with the TSC or TypeScript compiler. So just zooming out for a second, remember, TypeScript is a superset of JavaScript. It does not natively run in any browser. In other words, you have a build step, or not necessarily a build step, but a compile step, where you have to transpile that TypeScript syntax to plain JavaScript. And once it's compiled to plain JavaScript, then it can run in a browser. So that's kind of our goal here. And to do that, we need the TypeScript compiler or TSC. So here it's telling us to do the same thing as over here. So if we go back to Visual Studio Code, I am using the Yarn package manager. You can also use npm, but we'll just say yarn global add. This is the same as npm-g. Or npm install-g, and I'm going to add TypeScript, and I already have it installed, but it will install the latest version, and there's the compiler and then the TS server as well. Now Visual Studio Code I believe comes with this server, so if you hit Command P and you hit the little caret and then type TypeScript, let's see. It's not going to show up quite yet because we don't have a TypeScript file open. So let's just try something here. Okay, so we've created a TS file and I've added a basic type just to fill something up. And what you'll see down here in the bottom right is that VS Code has detected that we're using TypeScript, and it's kind of kicked off the TS server. I believe that's how it works. Leave a comment if I'm wrong on that. But if we hit Command P and then type a little caret, you can see that we can search for TypeScript and restart the TS server or reload the project. So just know that in the background, TypeScript, VS Code is working and actively looking through your code and recognizing the different types that are added. So let's go back to the documentation. It says building your first TypeScript file, and it's giving you basic TypeScript. And then it's saying you can compile it by passing the file name to the TypeScript compiler. And then I think it just goes through some like basic introduction to TypeScript, which this tutorial is not going to be necessarily an introduction to TypeScript, but more of a like, why would I need TypeScript and what does it solve for me? So it'll be a light introduction, but we're not going to really get into the meat of TypeScript. So let's go back and clear the terminal here. And with our index.ts, let's just define some variable equal to 20. And then let's give it a custom object type. Okay, so we'll say that some variable is a number, another variable is a string. And then if we assign this type to our object, now TypeScript is going to kick in and it's going to start telling you, that you've missed certain typings. So we've got these red squigglies because VS Code has detected that you are typing this object as a custom object type, which has these two properties. So we need to actually fill these in with their matching types. So if we put these in just like that and then finish off the object, now this is matching the type that we've assigned it. And if we tried to add an extra prop, it's going to yell at us because that does not exist in the type that we gave it. So anyways, the point of this is to just give a bare bones introduction to what TypeScript is doing, and we'll see how this kind of plays out to benefit us in the refactor. For right now, I'm just going to compile this. So we've got the TSC or the TypeScript compiler installed globally. Let's go ahead and check. So we'll pass the version. It gives us 4.9.5. And now let's go and call for help. So this will basically give you all the options, which is pretty overwhelming to start with. But you can see that if we just run TSC, it compiles the current project. So let's pass this file to it. So tsc JS, and then no, we need to get into our live TS refactor first. Now we'll say tsc JS index.ts, and you can see that we ran that command and now we have an index.js sitting over here, which is the compiled version of index.ts. So let's open up the two files next to each other. And what you're going to see here is TypeScript in action. Over on the left is our .ts file. This is what we're writing our source code in. And we're able to use custom typings and assigning those typings to a variable. Now, looks like something is going wrong here. And it looks like the two files are actually conflicting. So let's name this, let's put something at the end there, and it will solve this error for us. So just know that because they're in the same directory and VS Code is pretty smart, it's detecting that we have two variables that are the same name. Now, this is not going to happen in our final code because we're going to configure it not to, but just know that that's what's happening here. But anyways, the point is that we've got a type here which is actually not valid JavaScript code. You can't run that in a browser or Node.js or any JavaScript runtime. So what the TypeScript compiler does is it removes this type, and it removes this type annotation right here, and it gets us to this just vanilla JavaScript object that can actually run in the browser. So there's really two questions that come out of this. Number one, why would we want to do this? What is the purpose of adding these types? And then number two, how do we get more control over how this compiles to this? Because there's going to be different options that we can use to make that transformation happen. And furthermore, we don't want them going in the same directory, because obviously that screws things up with, variable declarations happening twice and so on and so forth. So there's some configuration that we can do to make this better for us. So let's go back to Excalidraw here and come down here and say benefits of TypeScript. So you could definitely go through a laundry list of things that TypeScript helps with, and there's plenty of people that go and do that, but I'm going to keep it simple here and just give one or two reasons why it is beneficial for your code base. The first one is just code checking in general. So in other words, it's going to, if you're using Visual Studio Code and you're using TypeScript, Visual Studio Code is basically walking through all of your code base and making sure that everything talks to each other appropriately. So we will see this in action as we start to refactor. But if we go back to our original application, let me delete this index.ts file and then the index.js. If we go back to our original project, which once again, if you haven't seen this already, if you didn't watch the prior video, at least make sure that you've skimmed over the code and know what's there. If we go to app.js, and let's try to find a good example of this. So here's a good one. When we are calling view.render and we are passing in all of our state of the application, these state objects have a certain type. And as you can see, Visual Studio Code is giving you some, suggestions as to what types these are already, even though we're not using TypeScript. And it's just inferring this from the function definitions over here in store. So it can read through the functions and it can see, what we are returning. So the return type here, and then it kind of infers, okay, what properties are on this object that was returned, so on and so forth. But if we go back to app.js, it doesn't really know what type anything really is. It can figure out the Boolean type, but the moves and the current player and the winner, these are all any types, because it can't really figure that out with plain vanilla JavaScript. And what's difficult about this and hard to maintain as your project grows is as you're typing things, quite literally, as you're typing on the keyboard and passing variables around in your application, it's very useful to know, are you passing something valid into a function? And TypeScript allows you to do this very easily. You'll really start to see this benefit as we start to refactor. So the second benefit that I have personally found with TypeScript is refactoring. So very suiting, for this video since we're refactoring stuff. But if you have a big code base and you're trying to go through and refactor an entire feature, it is extremely difficult to do so if you just have vanilla JavaScript and you don't have any strong typings throughout your application. With TypeScript, it's a lot easier because as you change things, Visual Studio Code or your editor that runs the TypeScript server is going to be able to tell, hey, did you move things around correctly? And are you passing, is your refactor going to break the compilation of the code? But enough talk, let's get started. So the first thing that we need to do now that we've got TypeScript installed and we kind of understand the general concept of what's going on, is get it set up for this specific application. So I know we've got it installed globally. If you use TSC and type the version, that binary is installed on our computer globally. But it's always a good practice to install it as a developer dependency within your project. And the reason being is, the global version is going to be different on each developer's computer. So if you're collaborating on a project, it's good to pin that TypeScript version for the application so that you have predictable builds and compiles when you compile that code to plain JavaScript. So to do that, I'm going to type yarn init and pass the -y flag just to say yes to all the options and just get a package.json file created. So here's our package.json, and we've got live TS refactor, blah, blah, blah. And the first thing we'll do is yarn add and then pass a -d for developer dependency. And then I want to install TypeScript. So now you can see devDependencies has TypeScript. Now, why is this a developer dependency and not a regular dependency? Well, this is super important, and the reason being is because, as we talked about, TypeScript is only going to happen before you deploy your application. So you write all your code in TypeScript, but obviously that's not correct, or it is correct. It's not valid for running in the browser or a Node.js runtime. So before you deploy your application, out on some server like AWS or Render or DigitalOcean, what have you, you need to first build it to the appropriate runtime that you're using, which is probably going to be CommonJS or ES6. So the point of having this as a dev dependency is to express the fact that you're not going to need this to actually run the application. You just need it to build the application to the point where then it can run. The next thing that we need to do is initialize a tsconfig. So this file is going to be a special file that sits in the root directory of your project, and it tells this compiler. So remember, TSC is the compiler. We don't want to use the global version anymore. So in this case, we can run yarn tsc to grab it specifically from the project, and then just run that, and it's going to try to compile stuff, but it doesn't find any TypeScript files to actually compile. So anyways, we need to set up a tsconfig to tell it how to compile things. So how we do that is we say yarn tsc, I think init is the right thing. So let's go to help and let's read through the options. Okay, so here's the start of the options, and you can see tsc --init creates a tsconfig.json with the recommended settings in the working directory. So that is what we want to do. So we'll run yarn tsc --init, and you can see that it created a new tsconfig.json, which we can open up here. And these are the options that it gave it by default. So let's go read through this. And right off the bat, you can see that there's quite a lot going on. So by default, it's going to have everything commented out. And we're going to get rid of all of this. These are just kind of all the different options. And you can go to this link here to view the reference for this. So the tsconfig. And it basically just takes you through all the different compiler options. You can click on these links to figure out what they do. But most of these options are not going to be relevant to, starting out, especially for a beginner. These are more of just options to control, your developer experience as you're building in a TypeScript code base. And also, of course, how it actually builds and compiles the TypeScript to JavaScript. So let's go ahead and get rid of all the comments just to see what it gave us. So these are the defaults that you're going to get. And we'll go from the kind of least important to most. Starting from the bottom, skip libcheck. This just tells TypeScript to ignore kind of the node modules .d.ts files. That's not super relevant here. Strict true. This is always going to be a good thing to turn on, because as you go through your code and write TypeScript, the IntelliSense that's provided by Visual Studio Code will make sure that everything checks out and all the types are consistent. So this is always good to have on. These two options are just related to some maintenance of your code base, so forces file naming consistency. This allows you to have interoperability between CommonJS modules and ES6 modules. So I actually wrote a whole post on this. If you go to my site, scripts versus CommonJS versus UMD, AMD, and ES6 modules. So this is a mouthful, but this kind of explains what that is talking about. And then most importantly is the target and the module options. So this is telling the TypeScript compiler what kind of code that needs to be output into code that can actually run within a browser. And that's our goal, is to get our TypeScript files to run regular JavaScript files so that we can just write our code in TypeScript, and then the compiler deals with getting that to a place where it can run in the browser. So let's go to the reference. We'll go to the reference guide here. So we'll start with the first one, which is the target. Now, I believe this is going to be in the, let's see, where is this? So just to orient ourselves, this is the compiler options field. So if you'll notice, all of this is defined in compiler options. And here in the language and environment section, you'll find target right here. Let's click on that. It'll scroll down. And it says modern browsers support all ES6 features, as we've been talking about, and we wrote our original project in. So ES6 is a good choice. You might choose to set a lower target if your code is deployed to older environments, or a higher target if your code is guaranteed to run in newer ones. So in other words, what target represents is the end state of the code that is going to be compiled. So we are going to target ES6 because that is going to mirror what we did the original refactor, the vanilla JS one. So you can see we've already got that ES 2016. You can pass a couple different options. I think it gives you all the options right here. But ES6, ES 2015, ES 2016, all the way up to ES Next. So let's just grab ES6 because we know that that's available in all browsers. I'm not sure why they did ES 2016 when they say ES6 is a good choice. Kind of mismatch in their defaults. But anyways, this is what the code compiles to. The next one is module. So let's go look at that. We'll go back to the top, and if you see modules, you will find the module property. This sets the module system for the program. And see the modules reference, you very likely want CommonJS for node projects. So not to backtrack at all, but going back to that post that I wrote here, scripts, CommonJS, ES6 modules, this really talks about these different module systems. But basically, if we look at, let me do a sample file. So sample.ts. Basically, if we look at, this syntax, import something from some library. This is what we would consider ES6 module syntax. Now, if we did something like this, const something equals require some lib. This is going to be CommonJS syntax. So the require syntax, and then also module.exports at the bottom of your file, this is all going to be CommonJS syntax. Now, if we do ES6, once again, it's import something from some lib, and then you can come down and you can export, some object or export default, and this will export things from your file, which is one-to-one with a module. So that's what that is talking about. And you'll see that it defaults to CommonJS, which again is a little bit of a mismatch. It says the default is CommonJS if the target is ES3 or ES5, ES6 otherwise. I'm not really sure, given this documentation and the fact that we're on the latest version of TypeScript, why it defaulted to that, but we really want to just have ES6 because we want to deal with that nice module syntax that ES6 comes with. And then going down the list, ES module interoperability, as I said, is the ability to basically combine the syntax that we just went through and have files from multiple module systems being able to compile together. This is going to be important, especially if you have certain libraries that still use old CommonJS module systems, or newer ones that use ES6 modules and don't support CommonJS. So having that interoperability is really nice, especially in larger projects. So at this point, we've gone through most of this, and once again, you can read through the documentation if you have questions on any other properties. But for now, I want to build a sample project just to get our bearings here. So let's make a folder called test.ts, and this is just going to have a test.ts file, just something to work with. And in this file, we're going to just define a sample type, and the sample type is going to have a name, which is a string, and an age, which is a number. And then we will say, let's actually call this a person type. And then we'll say const person is a variable, and this will be of person type. And then we will just give it a string, so Bob, and then age 50, something like that. So this is our basic TS file. Let's save our tsconfig. And now we should be able to compile some things. So the first question is, well, how does it know where to look? How does it know that we want to compile that test.ts file? Well, let's go ahead and try it. So yarn tsc and run it. And it says done in 0.73 seconds, and it obviously found the correct file to compile. So the question is, how did it actually know that? Well, let's go to the documentation and look outside of the compiler options at the top level options. Let's go to include, and this is an array that specifies an array of file names or patterns to include in the program. And then over here in the default, the array if files is specified, all otherwise. So as you can see in our code base, we ran the tsc compiler, and it automatically just looked for any .ts file in the entire folder and compiled it. And that's because it's got this default glob that is including everything. So given that behavior, I think we're fine. Now the problem with compiling your TS files in the same directory as where they're written is it just starts to get really messy. And then furthermore, you really want to output them into their own build folder. Now, there's a lot more to this subject in general, like creating a bundle, and that involves things like Webpack or Parcel or whatever have you. Now, there's a lot more to this specific subject. We could talk all day about, how things are compiled, where they're stored, all that kind of stuff. This gets into bundling and code splitting and, build tools like Webpack or Rollup or Parcel or whatever. We're not going to get into that because we don't need it for this simple of a project. Our goal is to basically take all of our TS files and put them in one spot, and then that will be imported to the index.html, and it will run just like our vanilla project would. So to do that, we have a option that we can specify, and let's see where it is. So looking under emit, this is probably where we want to look. And yes, here's the out directory. This is, if it's specified, .js files will be emitted into this directory. The directory structure of the original source files is preserved. See root directory if the computed root is not what you intended. So that's probably not going to apply for us. But you can see it gives an example where it outputs to a dist directory or distribution, which is a very common directory to output compiled files. So that's what we're going to do. We'll come back to compiler options and give it a out directory. You can see VS Code knows all these options, gives you some autocomplete. So if we specify out directory, gives us the documentation, which is very useful. And we're going to say that we want to put this to the dist folder. So we're getting some errors here, and that's because we need a comma. And once we save this and we rerun the compilation, now it's going to output everything into dist. And there's our test.js file. So you can see use strict is put in there, and we've got a person compiled. You'll notice that from earlier in the video, this is a different syntax than we saw earlier. Earlier we saw this was a var and there wasn't any use strict going on at the top. And that's because we didn't have a tsconfig. We didn't have all of these targets and modules that were specifying how we wanted things to be output. So anyways, this is the basics of compiling a TypeScript project. Now, our next order of business here is to look in our JS directory from our original refactor and convert these files to TypeScript. So I'll leave this test.ts folder for us. Let me get rid of the .js compiled file because that's now going to be over in dist. One thing that you would want to do here before we get too far is add a git ignore if you're working with Git, and put the dist directory as well as node modules because we've added both of those. Neither of those need to be uploaded to source control because node modules obviously can be installed by yarn, and then the dist directory is the build itself, which is going to be created with yarn tsc. So let's close out tsconfig. And let's start in the app.js file. So now that we're working with TypeScript, we can just rename this to .ts. And now VS Code is going to automatically recognize that this is a TypeScript file. And it's going to start underlining things, and it's going to yell at us for all sorts of stuff because nothing is typed here. Now, there are some strategies that you can use to migrate a JS project to TypeScript, but in our case, things are small enough that the best strategy here is to just rename all of these to TS so that we're dealing with TypeScript across the board. Now, if we were to go through and just try to compile this right now, it's going to throw all sorts of errors. And the reason that it does that is kind of the whole purpose of TypeScript. And that is, it's going to check the types and make sure that they're all compatible across all the files with the imports, exports, function calls, parameters, all of that stuff. And that's a good thing. That's what you want. But when we first start out and everything has these red squiggly underlines and TypeScript is really mad at us, it's not so fun. But I'm going to work through this. It's not as intimidating as you'll think. And we'll get this thing worked out shortly. So just as a reminder, the current project is no longer going to work because in index.html, we are importing app.js, and that does not exist any longer. We have app.ts. If we tried to replace this, it's just not going to work because TypeScript is not valid in our JS runtimes. So what we really need to adjust here I'm just going to do this right off the bat so that we don't forget, is now that everything's being compiled to the dist directory, we need to now specify, instead of JS, we're going to look in the dist directory and import app.js. So same thing as the original project, it's just going and looking in a different directory. Instead of the source code that, in our prior refactor was able to run in the browser, now we have to use the compiled code. And you can see in dist, it's going to maintain that folder structure. So we actually need to say dist/js/app.js. And you can see that it will, this has been compiled. It threw a bunch of errors, but it still compiled it. So we could probably get this to work actually. Let's just see real quick. The way that we'll do this is we already have live server running. I had this before the video. So it's on port 5500 and we're looking in dist.js app.js. So let's go to the vanilla refactor and instead we'll go to the live TS, or let's go to localhost 5500 live TS refactor, and let's see, it seems to be working. So even though there was all those type errors, it still compiled the JavaScript. And this makes sense because TypeScript is just a superset of JavaScript. So while not all TypeScript is valid JavaScript, all JavaScript is valid TypeScript. So in other words, when we went to compile these vanilla JS files just in a different form, it still knew how to do it. It just was complaining about all the types. So in this case where we're migrating an existing vanilla JS project, this behavior is actually good because we can, gradually migrate our code over and not break everything from the start. So there are some options though once we get to a more final state. If we go to the documentation, let's close some things out here. If we go back to this reference, there should be some sort of configuration property that allows us to basically fail the build if there are any errors. So we ran yarn tsc and it's going to give us all of these errors if we just look through them. But it's going to still compile all those files to our output directory. But just to demonstrate how you can change this behavior, I'm going to get rid of the test.ts directory now, just so that that's not clouding anything up. And then I'm going to completely delete the dist directory. So that's okay because remember, we can just run yarn tsc and it's going to create the dist directory. Interestingly enough, now that we deleted that other directory that had TypeScript, this now does not maintain the JS directory structure. So before I forget, I'm sure there's an option to change that. But before I forget, let's go and remove that path. And if we go back to our browser, let me get rid of this. Let's refresh and we can still play our game. So this is looking at the live TS refactor. So it's still working, but if we go to the options reference, there should be some options in the emit. So if we're scrolling through, there's this option called no emit on air. And I think that's what we want. Let's just scroll through a few more things. Okay, so let's click on no emit on air. This says do not emit compiler output files like JavaScript source code, source maps, or declarations if any errors were reported. This defaults to false, making it easier to work with TypeScript in a watch-like environment where you may want to see results of changes to your code in another environment before making sure all errors are resolved. So let's just take this property, no emit on air. We'll open up our tsconfig and we'll throw this at the end. So no emit on air, and this defaults to false, but we're going to say true. Now let's once again delete the dist directory, and let's try the yarn tsc to compile our TypeScript files. And now you'll see that even though we ran this, there's no dist directory because we've said if there are errors, do not emit any output files. Now, once again, we don't really want this because when we are converting our project over, we want the ability to just compile the TypeScript files with errors so that we get a build output. And then in a final state, you might, once you've converted your project over, you might add that back or have other sort of build checks to make sure that, you get a clean build before you deploy your application. So now that we have everything set up and we've got the app working with this dist directory, we will just jump into this JS folder. It's probably, not the best name for it anymore, JS, but technically, TypeScript is a superset of JavaScript, so it's somewhat valid. But what we'll do is we will start, I think rather than starting an app, which kind of consumes both the store and the view, let's just start with the store because it's always good to define the types of your state at the beginning. That just kind of helps you inform, the rest of the files and the project design in general. So this is just in general a good place to start. Now in this folder, I'm also going to make a new file called types.ts. And this is going to be a module that exports a bunch of types that the rest of our files are going to consume and pass around to keep things more clear in our heads and to also satisfy the compiler. So let me just reference my final to make sure I'm getting the right types here. Okay, so let's close this out. Our types will go on the left and then we'll put our store on the right. So the first thing that we'll see as we're going through, aside from all the red squigglies, is this initial state. So this is the shape of the object that we're storing in local storage, as you can see here. So if we open up our app and inspect, and we go over to storage and local storage, you'll see that I've already played the game, and you can see this updates on every move. And if we open this up, you can see the parsed values. So we've got the current game moves, the history, all games, current round games, and then you can go through and just see all of the moves that have been made by the different players. So that is the shape of that object that we're storing in state. Now, the benefit of TypeScript is to just have confidence over, the types we're passing around. So it would be a great idea to define that state. So in TypeScript, you define a typing with either the type keyword or the interface keyword. The difference between the two is a discussion for another day. I generally prefer types, but some people will get very heated with a discussion about which one is better in which situation. But we'll start with just a type, and I'm going to call this the game state. So game state is an arbitrary name I'm giving this type, similar to how we would, define a variable name. And the type is defined using, basic object syntax. So I'm just going to match this. So let me copy this shape over and get rid of this comment. So right now, this is not really a valid type. It's not really complaining about anything, but this is not a valid type. Let's go ahead and give this a type of, current game moves. Let's just say it's any for right now, and it's going to be an array. So it's going to be an array that has objects that have any shape. So this is just our starting point. Now we need to define all of these types right here. So this is kind of our final thing that we need to get to, but we need to decompose our types into smaller units so that we can pass them around our files a little bit easier. So the first thing I want to do is define a player. So you can see that we've got squiggly lines under the player's param or argument that we're passing into the class constructor. And if we were to open up the app.ts, you can see the players array that we've defined. So let's give a type to these objects. You can see that they have the same exact object shape. So we can give this a representation of player. And a player is going to have an ID, a name, an icon class, and a color class. Now these are the actual values, but we want to give these a type. So a 1 is going to be a number type. Player 1 is going to be a string type. The icon class is also a string type, and the color class is a string type. So here we have defined a player type. Now you'll notice that all of these just have regular, primitive typings, and they don't have anything crazy going on here. Now with TypeScript, you can make a property optional by adding a little question mark after the property, or I guess I'm not sure if you'd call that a property, but you put this question mark here, and now the color class would be an optional property. So you can hover over it and it says it's either a string or undefined. And if we remove that, it is just going to be a string. For our game, since this is a configuration property, we want this to be all required properties. So this is the correct shape. So now what we can do is go back to store.ts and move on to the next type that we'll need. This does not satisfy anything that we've got going on here, but it will be a building block for us to work from. So the first thing I want to do is define the current game moves. So what is a move in our game? If we scroll down to player move, you can see that what we're pushing to state is a property with a square ID and a player. So we just defined the player interface or type, but what is square ID? Well, this is just going to be a number, and we can define this as a move. So let's call it a move, and it's going to have a square ID, which is a number, and then a player, which will basically be this type right here. So if we hover over move, you can see that this is the type that we've given it. We can now take this move type and replace the any type in the current game moves with move. So now the current game moves is an array of moves, and that lines up with what we've done here, where we are pushing a move to the array of current game moves, which is our state. Now to figure out what we're going to type the history object with, we need to go down into the store class and figure out what we're doing. So in the reset method, what we are doing is pushing games to the history object under the current round games property. So this is the type that we're looking for. We are pushing an object that has a moves property and a status property. Now it's pretty clear what moves represents. Moves is going to be what we just defined, an array of moves. So we can start with that, and we're going to call this a game. So a game is going to be represented by an array of moves, and then we have a status property. We don't really know what that is yet, so let's give it a type of any to start with. And now we can kind of go look through our code base and define what that type is. So if we track backwards and look at status, it's coming from a destructured property off of this.game. And if we look what this.game is, that is a getter method on the class, and the return type of that getter method is all of this stuff. So we have a moves array, we have a current player, and we have a status. This object right here, the status, is what we are trying to define. So let's make one more type called game status, and that's going to be an object with an isComplete property, which is going to be a Boolean value, as you can see. And then the winner is going to be a player. So the winner is going to be represented by a player, which we defined right up here. So now we can take this game status, and this is going to be the representation of status within the game type. So once again, we're coming down here, and this is where we're pushing a game to the history of current round games. We've got a moves property, which is now represented by an array of moves. And we have a status property, which is now represented by a game status, which has this type. And now we're finally ready to replace some things here. So we have a game and a game status. Let's put game right here for current round games. Now the last thing we have to fill in is the all games. We have to figure out what type of array that is. And I'll just save us some pain of looking through this and just say it's going to be the same thing. So the current round games and all games going to have the same exact type. At this point, we have defined all of these supporting types for our game. And in this case, we had just looked at our reference code, our JavaScript, and we are basically just looking at, what kind of objects are we passing around? What are we returning from our different functions? And we're just looking and analyzing our code to see that information. If you were starting this project from scratch and you intended to use TypeScript all the way through, this is actually a great exercise to go through before you even write any code. Defining the types of your game is a great way to define the functionality behind it without writing any code. It's actually one of the first things that I will do when I'm building a new feature is just map out the different types that I'm going to be dealing with. And then I'll figure out what functions do I need, what types are going to be accepted as arguments to each of these functions, what are the return types of these functions, so on and so forth. So as you can see, TypeScript is already making us think a lot more clearly about what types of objects we're passing, objects, arrays, so on and so forth, what types we're passing through our code. And it makes us a lot more explicit about that and more organized. So if we go back to our Excalidraw, where I was briefly listing out the benefits of TypeScript, I think one of the other benefits is makes you think more clearly and explicitly about your code. So that's what we just experienced. We're having to explicitly type out our game. Now, at this point, we still have squiggly lines, and that is because we have not assigned these types to anything here. So I will keep both of these open. I'm going to just collapse this a little bit. And let's just start working from the top of our file. So the first thing let's look at is the constructor. With TypeScript, we can add types to things by adding a colon and then giving it a type. In this case, the key is our local storage key, and that's just a primitive string type. So we can just pass that in directly. We don't need to do anything over in our types file because, we don't need to redefine a string. Now, players is going to be an array of players. So we'll give it a colon, and then we will say player and then array. So that is going to be the type we're dealing with. Now you can see that it figured out that type already, even though we didn't import it. Now, this is not always going to be the case. It works okay here, but generally what you'd want to do is import that type explicitly. So with ES6 modules, what we can do is import a type, and then that type will be called player, and that type will come from the types file. So types.ts is what we're looking for. Now you're going to see an import path cannot end with a TS extension. Consider importing types.js instead. Let's Google this. It's probably some configuration property that we missed. This person is just saying that we can just remove the extension. Let's just try that. I don't think that worked. Now it's saying that types.ts is not a module. Oh, I actually know what's going on here. I'm sorry. I messed this up. So these are all just scoped to the types.ts file, and it's also not saved. So that would be a big problem that we cannot import that. So the first thing we do is save this file. That will help us out quite a bit. it will not solve this error because we have not exported any of these from the file. So to use them throughout our code, we need to export them just like we would export, if we had some variable equals 20, and then we export some variable or export default, something like that. Or we could just export it like this and it would do the same thing. And now we can, import some variable from the types file. So that's just a regular JavaScript variable. I will get rid of this and let's keep exporting all of these. Okay, so we've exported all of our types. Let's save it. And now we should not get so much grief from the TypeScript server. Now there's no red squigglies. We've got the player type, and you can see we can hover over it and you can see that type, which is really nice to just be able to hover over this. You can also hover over it down here. And now we have a strongly typed constructor and it knows exactly what's being passed in. But at this point, we get these problems. Storage key and players. These are instance properties of the store class. And since we have not explicitly typed those, it's complaining. Now, one way that we could do this is come up here at the top and say that storage key is a string. And that will satisfy it because we're passing in this key. And then in the constructor, we are assigning this to a string. So there's actually a shortcut to doing this, a more concise way to do it. And instead of calling this key and then this storage key and having that mismatch there, we can short circuit this, delete that, rename this to storage key. And so far it's not going to do anything. So if we tried to assign this .storage key equal to storage key, it's not going to work. We can remove that entirely. Now this is not going to work, but if we say this is a read-only property of the class, it will define it so that we can access it later in the class. So if we go to the bottom where we are saving the state, you can see we're accessing this .storage key in these two places. And if we hover over that, it's going to know that it's a string. Now, if we come to the top and we get rid of that read-only and just leave it to storage key, it will complain about that because it says it does not exist on the type store. So all we need to do is give it a read-only, and you can also give it either a public or private just to define whether it's accessible from outside the class or not. We'll call it private because only the internal methods of this class can access this. And then same goes with players. So once again, we can delete all of this. And this can just become a private read-only array of players. And so right here, this is basically the shortcut for passing in these parameters and then assigning it to the class all in one step. And you can see if we look for this .players, it knows that it's of type player. All right, so we're getting closer. We're seeing a lot less little squiggly red lines. We just have a few more things to work out in this file. Let's go ahead and start here at the bottom. This is pretty isolated. So this state or function has an implicit any type, which basically means TypeScript is yelling at us because we haven't defined any type. One thing that we could do if we really wanted to, as we are refactoring this and migrating our code base, if we change strict to false and save that and then restart the TS server, you'll see that this no longer complains about this at all. We can define this as an any type and TypeScript's not going to be mad about it. This, of course, comes with the detriment that now you don't have any red squiggly lines to tell you where you've messed up. That is why most people would encourage you to put on strict mode. Restart the TS server here. but I just wanted to show you that just so you can see. Now let's start at the bottom here. Again, state or function. This is a great use case for TypeScript. This is where your life becomes a lot easier. And that is because in this case, we are allowing someone that is using this function to pass either an object that represents state or a function that we will pass the previous state to, and then it returns a new state. So two different types of parameters that you can expect here. And so we can type this a lot better now that we know, or now that we're using TypeScript. So saving the state, we are going to be passing game state. So that is the type that we're looking to pass in there. So we'll say game state, and it's going to complain about this because it cannot find that name. Let's go to the top and let's import game state from our types. So we're importing that type. Now it's not complaining anymore, but it complains right here because it thinks, this function thinks that state or function is just an object that is represented by game state. And right here, we are trying to call it as a function. So the problem here is that we've only defined one of the possible types. So here we can define a TypeScript union. Let's go to the documentation and briefly look at this. So let me make a new tab, and TypeScript docs, let's start over. And let's go to either the reference or the handbook. I'm a little surprised that we don't see unions starting out, but let's go to the basics. That's not what we're looking for. Let's just search the docs. So union, TypeScript unions, looks like TypeScript for functional programmers is where we found that one. But anyways, in TypeScript, union types are untagged. In other words, they're not discriminated unions like data in Haskell. I don't use Haskell, so I don't know what that means. But what this is trying to basically say is that if you put this little pipe character, that means that the type can be, either this or that. So it's kind of like an or operator, but for types. So you can read more about that, but let me just show you what this looks like. It's going to be game state or, and then this is where we define our function that we're looking for. So the function is going to be a separate type, and I'm going to actually add this to, let's add it to the top of the file. So since we're in TypeScript, we can just add types within our files. So we'll say save state CB for callback. And to define a function, there's a couple ways you can do it, but one quick way is to basically just give it an arrow function and tell it what it needs to return. So in this case, we want to return the game state, and we're going to pass the previous state, which is going to be a game state. So basically, I talked about this in the previous video when we did this build, but it's always nice in your save state function to be able to access the previous state so that you can derive that next state. So that's why we're passing this, but this is the type that we can define. And if we took this key right here, the type, and we passed it right here, save state callback, you'll see that there's no more complaints from the TypeScript server compiler because state or function matches the type that we gave, and previous state is not typed yet, but it satisfies that constraint. So I can actually take this to be a little more concise and copy that type itself and just pass it in right here. And then you need to put some parentheses around it, and that should work just fine. Now we can get rid of this. I just wanted to break it out so that it was more clear. Now everything's working here, but if we hover over previous state, that's going to have an any type, which no one's complaining about this here with TypeScript, but it would be nice to know what that is. One way that we can do this, and this is a little bit tricky with TypeScript, it's not super obvious, but when we do local storage.getItem and setItem, it's not going to return a type. So getItem is going to, by default, return in any type, or actually, sorry, a string or null. And the JSON parse method, this is where it's going to return in any type. So what we want to do, if we want to actually give this a strong typing, is we will cast the type. So we can say json.parse item, and then this is going to be as game state. So now get state is going to have a return type of game state. And you can actually explicitly define that on the function itself. And if we remove this now, and we say as string or something like that, it's going to yell at us because we're not returning the correct type that this function was declared as. Now, that's for a whole nother day. We're not going to be typing all of our functions explicitly with return types. Some programmers really like that, to be explicit about typing all the functions. This is just a refactor, and I just want to get this working. So for the moment, I'm not going to worry about that. But just know that you can define the return types on your functions. So now that we have done this, we can come back here, and previous state will be a type of game state, and it still works to pass it into state or function. The game state can go into state or function because that is what we typed it as. All right, let's keep scrolling up. I think we have one or two more errors. The square ID, this should be very easy. Let's just give this a number. That's the expected type. Now, if we hover over current game moves, we would expect that to have the move type, but it does not. It has an any type. And I believe we can fix that. Where would we fix that? One thing we can do is give this initial state a game state type. So now anywhere we pass that, it's going to recognize it. So right here, the initial state is of type game state. So if we look here, the structured clone method is actually similar to local storage, where it's a browser API, and by default, it's not going to type anything. So in this case, we're going to cast this to a game state object because we know that this state is going to be represented there. So now where we're pushing to all games, it's going to recognize that current round games is of type game. So you can start to see how this comes together and how we are starting to get stronger types across our code. Okay, so I think the only thing we have left here is that red squiggly. Not saying that the red squiggles are your map necessarily. You obviously need to check other things, but just given the fact that we know that this code worked before and we have strict mode on, we can really use those as a guide for our refactor to find areas that we have not strongly typed things. So let's dig into this error. It says property includes does not exist on type number array. Do you need to change your target library? Try changing the lib compiler option to ES 2016 or later. All right, so it's gonna say 2016 or later. So this is ES 7, I believe. So let's target ES 2016 and then restart the TS server. And now you can see that will go away because that built-in method on an array is available in the ECMAScript 2016 spec. So we are, let me be clear about this, we are using ES6 modules, which tells us how we can export and import things from modules. And then we are compiling our TypeScript code to this standard of JavaScript. So that standard of JavaScript has this method. And at this point, we have completed this file. We've imported our types that we need, and there are no red squiggly lines, so that's a good indication that we're pretty much done with this file. Let's save that and go to the next one. So we are done with the store. Let's go to the view. This one will be slightly more difficult because we're going to have to deal with DOM element types, which are a little bit more confusing. So we've got a bunch of red squiggly lines here, but they're all coming from this query selector helper method that we defined. Let's go straight down to that. And let's start typing it. So the selector itself is just going to be a string. That's like the class or selector that we're passing into the query selector method. And then when we're typing things with TypeScript, something useful you can do is just hover over these methods. It's not going to work because we're using it on the parent, but if we go to the document, there's some built-in types for the DOM methods and global types. So document is of type document, and query selector, this will give you a stub giving you the types that are available here. You can see the selectors are of string. That's how I knew to give that a string. And then element is what's going to be returned from it. So we are going to pass a parent, which is of type element. And now we should see that's of element, and then query selector is now available on that. And we're passing in a string. So let's retype this to a number real quick, and you'll see that that's an invalid thing to pass to a query selector. So that's how we know that string is going to be the correct thing. And then furthermore, we can go to query selector all and just give that a string type as well. So these two methods are now strongly typed. And if we come to the top, it's still going to be yelling at us just a little bit. It's saying it expected 2 arguments, but it got 1. So what we have to do is come down to our methods. And in this case, the parent element is totally optional. So what we can do is pass a question mark right after that, and that will now make this an element or undefined. And that's okay because we are first checking with our ternary operator whether that parent argument has a value. And if it does have a value, we're going to use it. Otherwise, we're going to fall back to the document. So if we were to refactor this a little bit and intentionally break it, if we just tried to access the parent element and grab a query selector off of it and then pass the selector, it's going to work because Visual Studio Code already knew what we were trying to do. But if we remove that right there, it's going to yell at us because it says parent is possibly undefined, and you can't access a method like this on an undefined parameter. Now, you'll see that VS Code added this question mark here, which is the optional chaining. So let's type that in, optional chaining. This is actually not a TypeScript concept. This is an operator in newer versions of JavaScript, which we're using, that accesses an object's property or calls a function. And if it cannot find what it's looking for, if the type is undefined or null, as shown here, it will short circuit and evaluate to undefined. So the reason that works to do this is because this operator right here is just checking, hey, is the parent element defined? If it is, let me call this method. Otherwise, let's turn element to undefined. And then as you can see here, we're checking if element is defined, throwing an error. And if it's not, or if it is defined, we're returning it. So that technically does work. But in this case, we want to use this logic just to be explicit and say, if it exists, grab from the parent, otherwise fall back to the document. And that gives us assurance that we're going to find that element. So we've fixed all these red squiggly lines, but now we have a problem here. And it says property menu does not exist on type object. And you can see here we've defined this as an object. What we really want to do is retype this, and we're going to use a built-in TypeScript utility. Let me make sure I'm doing this the same as my example, or my final. So if we go to the documentation for TypeScript, let's go back and find ourselves the utility types. So in the reference, there's this utility types. And if you come over here to record, this constructs an object type whose property keys are keys right here, and whose property values are type right here. So this is actually leveraging something called generics in TypeScript, which is kind of beyond the scope of this video. You can look it up and read about it. But keys and type are going to be generics, and record is going to be the type that allows us to define something. So in other words, this is just basically defining a basic object. So right here, this is where we will type this. So remember, $sign is just a property, an instance property of the class. You could have named this pretty much anything. So you could have named this element, object, store, or something like that, but we're just doing this for a shortcut. And if we want to type it, we can type record, and then this is where we pass our generic values. So we want to pass a string because we're defining arbitrary strings as the properties of this object, and then the value is all going to be the same. It's going to be an element type. So if we pass in element, now things are satisfied here because we are passing an arbitrary string property name right here, and then the value is going to return an element, which, as you can see down here, we are returning a type of element, so that is satisfied. So all these are happy now, but we need to type the double $sign, which is the node list. Now, if you come down here to query selector all, let's just take a peek at what this element list is. It is typed as a node list of elements. So that is the native typing that the query selector all built-in method is returning. And you can see that's defined right here. So let's just copy that because we'll need it. Come back to the top, and now let's define this as a record where we can give it an arbitrary string. So squares is an arbitrary string property name. And then the type that we're going to give it, we'll just paste that in. So it's a node list of elements, and we'll initialize that to an empty object. And now the element list is happy because query selector all returns that node list of, and squares is that arbitrary property value. So it satisfies this type. So that's just a use of a built-in utility type in TypeScript using some generics. I just want to show you another way that you could have done this. So if you wanted to not use a utility type, what you could do is define a custom type. So let's say element object dictionary. That's just our type name that we're giving it. And here what we can do is pass in a key of string, and this can be an element value. And then we'll pass this element object dictionary. I'm sorry, it should not be of, it should be in string. So what this is basically saying is I want an object that can have an arbitrary number of properties, and the key of that property, so menu, menu button, menu items, is a string, and then the value of that property is an element as assigned here. So this type right here is really the equivalent to what we did earlier, where we said record string element and then closed it off. And if you really wanted to get fancy, you could do this with generics. So sorry, I'm going on a little bit of a tangent here, but this is just to give you an idea of the power of TypeScript. So we could say custom record utility. So what we're trying to produce here is the built-in utility record and just recreating that from scratch. What we can do is pass in a generic, so a key and a value. And usually with generics, you're going to put a T in front of it. That's just kind of a convention that I use to kind of signify or express this as a generic. And then we'll use the same syntax. So the key is in T key, and then the value is T value. Now we know in JavaScript the only valid type of property you can give an object is really a string. You can't just define an object like this and start adding numbers to it. Like this is, I guess this might be valid. Is this valid JavaScript? Oh, that's funny. I guess I don't know. I don't think this is valid, but let's just try it out because now I'm curious. I wouldn't be surprised. So we'll say this is a test. And it looks like it is. That is interesting. I didn't know that you could do that. I don't know why you would ever do this other than maybe a map, which is kind of similar to what that does. But anyways, I guess I learned something new today while making a tutorial about coding. That's probably not the best thing, but anyways, let's just be honest. So anyways, we want this to be a string. So let's just say it extends a string type, and now that's going to be fine. And then we can just replace this record with custom record utility, and it's going to work fine. Everything's going to be happy because we've basically just implemented that built-in utility type that TypeScript provides. So just an interesting tidbit that you can kind of mull over a little bit. So let's get rid of that because that is unnecessarily complex. You can see at the top here, I had imported the store just for JS doc typings when we had the vanilla JavaScript project. So now that we're using TypeScript, we really don't need to do that. So we'll get rid of that. So moving down, we can now implement the rest of these. Okay, so we'll move on to the render method. The render method takes two state objects, and the reason I originally passed this as two separate objects is because we were not working in TypeScript. Now that we are working in TypeScript, I probably would just pass the entire state object as one parameter, but we'll stay consistent here. So if we look at our types that we've defined, we have a game type. So that one's pretty easy. We'll just type that as a game. And we need to import that, but instead of going to the top of the file and doing it there, I'll show you a little trick. So if you hold down on a Mac or on a command or on Windows Control, so command and then period, and VS Code will give you a suggestion, and usually it can find out where it's looking. Now it's looking for types.js, not types.ts. I'm not quite sure what's going on there, why it's saying that. I don't even know if there isn't a types.js. I'm not sure what it did there. But anyways, we'll add the type import just so it's not importing anything but TypeScript types. And then we can remove that extension, and that should work. So now that's working. Let's see if it works on this one. So we need to do stats, where I don't know if we have typed that yet. Okay, so I've actually, in my final copy of this that you'll see on GitHub, I've used a slightly different strategy. So we do not have a type already defined for stats. If we go to store.ts, the object we're looking for is this one. And specifically, we're looking for this return type, which has a player with stats, which is an array of players with this wins property added. And then we have ties, which is just a number. Now, if we hover over stats, it will give us this inferred type, which is correct. And furthermore, the store class has an inferred type that has all of the methods on it. So something that we can do is derive types from other types. And in this case, since we don't have a stats type, what we can do is go back to the view and we can import type store from store, and that will give us the store class that we had defined. And then here, what we can do is say store, and then we can actually access properties on that. So you can scroll down, just like we're accessing, properties of an array. We can scroll down and see all the methods and properties that we can grab from the store. And stats is one of those. So now stats is defined because we derived it from the store. Now, some would argue that this is maybe not the best way to do this. And I would probably recommend having stronger types and actually defining a stats type. But for now, this does work, and it's an easy way to get that type without having to define it. We can also grab the game getter from the store, which will properly type our game. And that is going to give us the correct types for the render method. And again, I'm using this to demonstrate something. In reality, you'd probably want to define these as actual types over here. And we do have that for game. So we could use game scrolling around. We could just use game right there. But actually, it will yell at us because this game is slightly different. This is derived state. So this game is the state that we're storing in local storage. And then the game that we're trying to represent in this method is derived state. So in our store, remember we have this method called game, and we are reading the state, the raw state, and we are deriving some useful properties that we're returning for our game to use right here at the bottom. So obviously current player is not saved in local storage and not represented in this type. So I guess that's another reason why just using the store game is a good way to do it. But yeah, basically I would say that you'd want to type this function. Now coming down to the bind events, all these methods, the handler is of type any right now. But basically what we're passing to the handler is the callback of add event listener. So if you look at the stub for this add event listener, you'll see it's got some overloads, which is kind of an advanced TypeScript concept. But one thing you can do to kind of zoom in on some types, let's command click on add event listener, and this will take us to lib.dom.d.ts. These are the typings for the DOM that are basically provided already to us. And if we open up this in the file pane, I don't even think you're going to see it because this is kind of, I believe this is built into VS Code just to give you these typings. I could be wrong on that. But anyways, add event listener, it gives you a couple types that you can deal with here. And then you can hit command click on this, and then you just kind of go until you find the type that you're looking for. So event listener. And now you can see event listener is actually a type that we can use. So we don't even need to define it. We can just use event listener, which you can see is populated, and pass that right there. So event listener. It's always best to use built-in types if you can. If they're not defined, then you obviously have to type them yourself. But with something as common as an event listener handler like this, you can always expect that there's going to be a type already defined for you that you can use. So those are done. Update scoreboard. I believe these are all just numbers. So say number, number, and number. Here it's going to tell us something. Inner text does not exist on type element. I might have used this wrong in my original, actually. I think this should be text content. Yeah, so that's actually the right thing to use. I don't know why I was using inner text. It seemed to work though. So let's update all those. Open modal message is just going to be a string because we're passing a string of who won. And then we have the same error here that needs to be changed to text content. Coming down to initialize moves, this one is somewhat simple. We've already defined the move type over here. So it's going to be a move, but right now it's going to complain because it cannot find it. So hit command period and we'll update the import. And you can see that that actually added the move right there. And we're not using game anymore, so we can get rid of that. But now it's going to complain right here. And that's because I've intentionally messed this type up. We want an array of moves, not just a move. So to specify that, we can either say array, which is a helper utility of TypeScript, or you can just do it shorthand and pass the brackets at the end of it, which specifies that moves is now a moves array. So now this is valid and you can see everything's working. Just to start demonstrating the value of TypeScript, let's say that we removed this plus sign. So in the original build, I remembered to do this, but it's pretty easy to forget to cast the ID that you extract from the element target to a number. So what if I got rid of that? Now it's going to yell at me because it's an unintentional, because types number and string have no overlap. And what that's saying is we are doing a triple equals equality, which checks the type and the value. And we're looking at a move which has a square ID of number, and then the default event target ID is going to be a string. So element.id is going to type to a string. So these will never evaluate to true. Now we could of course remove the triple equals, and that would technically work because things would be cast, but you always want to use triple equals if you can. So here, that's just a very explicit example of where TypeScript comes in handy, is it reminds you of these little details that you might have kind of glossed over before. All right, so let's keep going. You can see that it's complaining here about icon possibly being null. And this is just a case where we could do better. So remember earlier in the prior video, actually, not this video, we defined query selector. And this is like a safe query selector where we are checking whether the element exists. And if it doesn't, we're throwing an error, which is kind of the behavior that we want. We don't want to proceed if we can't find the element. So one solution to this problem is to put a question mark there, because that will be the optional chaining that we talked about earlier, where we're saying, hey, let's check the icon, and if it's an element, grab the class list and add this to the class list. If it's not an element and it's null, let's just evaluate this to undefined and not throw any errors. Now that works. You could add that there and it solves your problems. But this is kind of an anti-pattern a little bit, because you throw this in here and all of a sudden your app is not grabbing this correctly and you're clicking your toggle menu and it's not working. Well, how do you find that error? It's better to be explicit about this kind of thing. So let's leave that and take some clues from TypeScript and refactor this to instead, let's comment this out and say icon is equal to this, and we'll use our safe query selector method. in this case, we're going to look for an I tag, and the parent is going to be this $.menu button. And that is basically how we can safely select that. And now icon is definitely an element because we're going to throw an error if it's not. So these calls down here are now valid. This is actually a concept called type narrowing that you can read more about in the TypeScript documentation. So I wonder if this is actually somewhere I can show you. Okay, yeah, so narrowing. And this whole page kind of describes that process of narrowing the types that I just explained here. Same thing goes right here. We can just copy this down and replace this. Let's get rid of this, and these two functions are good. Now, a couple more. The square element, you can see that we are replacing the children on it, so we know that that should be an element. And then the player is going to be a player, and command period to update that import at the top. Same thing here, this is going to be a player. And then finally, we get this fun delegate method that we really, it's tough to understand in the first place, and now we have to type it. But let's just walk, parameter by parameter and get this done. So element, pretty self-explanatory. This is going to be an element. The selector is going to be a string. The event key is going to be a string. And then the handler is going to be an event, what do we call this? We have an example of this right up here. Event listener. Now we've got a little bit of a tricky situation. So you can see right here, event target is possibly null. So okay, let's put that question mark, the optional chaining. But we still have this problem. Property matches does not exist on type event target. So we're going to use this narrowing concept again to narrow these types and get rid of these errors. So this is where TypeScript is actually helping us in a way. It's kind of making us more explicitly check things that we otherwise probably wouldn't. So the first thing that I want to do, let's get rid of this question mark. Or no, we'll leave it there for now. And we'll say if the event.target is an instance of element. So this is a way that we can check if the target is an element. So if that's an instance of the element, and we actually want to negate this, so if it's not an instance of an element, then we want to throw a new error. And we say event target not found. So this is just a guard that basically says, hey, the purpose of the delegate method is to delegate an event target and find something within it. And if we can't find that in the first place and it's not an element, then the rest of this method is useless. Like we can't really proceed safely. So we might as well throw an error, exit early, and then the developer is responsible for fixing that. So that solves one of our problems. The matches keyword or function now does not complain about anything. Now in the handler, it says argument of type element is not assignable to parameter of type event. And that is actually because I typed this incorrectly. In this handler, we're actually passing the element itself. So I have typed this as if we were passing the event, but really what we're passing is the element. So I need to type it accordingly. So we're just passing a function that is called with the element as the first argument, and it doesn't return anything. So now there's nothing wrong here and we're okay. But let's remove this question mark and see what happens. So looks like we're okay. All right, so we're good here. This works. It's typed okay. And I think this whole file is now strongly typed, and we're ready to move on to the final one. app.ts, and we're going to tie it all together and get it working. Now, just as a reminder, this app, really we haven't done anything structurally to it other than a few things, so it should still be working. And if we open things up and ran yarn tsc, let's look at the dist directory. It outputs everything. And then if we go to our page, let's inspect the page and go to the end of the body. And you can see the script is looking in dist-app.js. And if we click things, we can play the game still. So there's really nothing that we've changed, and it's been working this whole time. We're just trying to make our project more maintainable with TypeScript so that if we want to extend it in the future, it's easier to do so. Want to debug it, easier to debug, all that kind of stuff. Okay, at this point, by fixing those other files, we basically fixed a lot of the typings here in these files. Now, it's always nice to just be pretty explicit about your typings. Some would argue that you want to infer types as much as possible, but let's just go ahead and add a player type to this array. And once again, it's trying to go to types.js for some reason. So we've got type player, and this is an array of players. Now, remember the store, we've typed that, so you can hover over it. And you can see the storage key should be a string, and the players should be a player array. So this is a player array, and this is a string. Let's say that we passed in a number. It's not going to be happy with that. It'll say number's not assignable to type string. So that's kind of the assurance that we're getting here. Now coming down here, let's see what it says. Property ID does not exist on type event. So this is actually, I think, a mistyping that we had from the bind player move event. Let's go back to the view. And you can see this is where we're using our delegate. And then our handler, we've typed that as an event listener. And if you remember down here, I made that same mistake where I was incorrectly typing the handler. So let's copy this handler type. And instead of event listener for the handler, it's just going to pass a function with the element that it selected. So now we come back and these type errors are fixed. So this, fixing type errors is really about just reading the error message and being able to, respond to it and know what it's trying to say, which comes with time. It's not easy to start and figure that out when you're first starting with TypeScript. All right, so at this point, everything is strongly typed and our app is working. So our last step here is to compile things. Let's make sure that we're not getting any errors. So yarn tsc, and there's no errors. We're done in a second. And the dist directory now has our compiled code. And as you'll see, as you read through this, none of it's really minified or anything like that. And our target was ES 2016. So you'll actually see all of these methods that we are using. Let's see if we can find the includes method. Here's some interesting stuff. This is TypeScript dealing with like the class syntax and private fields and properties. It has like a helper method to deal with that. So that is kind of interesting. So let me just show you, if we downgraded this to like ES3, a prior spec of JavaScript as our target, I just want to show you how that plays out with the output. It'll be tough to see, so let's open up view.js and just kind of watch the code as we recompile this to a different target. You can see that all of this stuff changed. And if we go back to ES 2016 and then recompile, and you can also see we get all these errors because we're using language features that were not available back in that ES3 spec. So the compiler is going to give errors. So now let's go back to our valid syntax, and you'll see like this will update. So you can see the modules that we're using. But anyways, that's just a kind of fun little tidbit to kind of explain that tsconfig a little bit more. But I want to wrap this up by just walking through why this was so important to refactor to TypeScript and why someone would go to the effort to do this. The value in TypeScript does not really come as you are, retyping things. It comes when you're trying to refactor things or add new features. So if we went to the JS folder and we went to, let's say, the store, and let's say that we came down and we wanted to, change the type that stats returned or something like that. Well, if we went through here and let's say we updated this property wins to like win count. Okay, so it's not going to complain at all right here. But what you'll see is that if we try to recompile this, so yarn tsc, it's going to give us errors that were no longer there. And the reason being is in our view on line 59, so let's open the view and go to line 59, you'll see that we have this underline because we are referencing the output of this stats getter from another place in the code base, and we are using the original property. So we would need to update that to win count before it's going to stop complaining. And what TypeScript has done for us there is, as the developer, you're going through and you're changing a method. And this method is depended on by other methods in other parts of the code base. And so TypeScript is smart enough to know, like, hey, if you change this, and it does not match up with the rest of the code base, we're going to not compile this code base because it's just not going to work. So otherwise, if you had a vanilla JavaScript code base and you try to do something like this, nothing would happen. You would just think, oh, I'm okay, I changed that, that's fine. And then you would find out that you had errors in your project once you started playing the game and it was not working as intended. So that's kind of the benefit of TypeScript is you get that proactive checking of your code and you find out about errors a lot sooner. So rather than pushing a bunch of code up to GitHub and deploying it and finding out that something's broken in your app, you just don't, it just does not get deployed correctly and it doesn't build correctly if it's not correct code. So that's kind of the appeal of TypeScript. I'm going to put this back to wins now. Now, like I was saying, you would probably want to type this a little bit stronger. So if you were going back to this stats getter, what you can also do is set a return type on this. So if we wanted to open up our types.ts file, let's bring that over here to the right. And maybe we wanted to actually annotate the expected return of this function, which is usually a good idea with functions. It's better to be explicit, and I'll show you exactly why in a second. So let's say this type is called derived game state or something like that. And you don't have to define this here. You could define it in this file itself. And I would actually say that that's probably the better place for it because it's specific to this file. So let's actually get rid of types.ts and we'll open this same file twice just so we can edit it in different places. And I'll usually throw types at the top of the file. So derived game state, and that is what, or actually we don't want to call it that. We'll say derived stats is what we want to call it. And now I'm going to assign the return value of stats to derived stats. And as we see it right now, looks like nobody's complaining, and that's because we've defined this as an empty object. But let's say that we defined it as a string. Now this is going to complain because our return type does not match the explicitly annotated return type that we had assigned it. So now our job is to define this, and we can see that ties is an easy one. That's going to be a number. So you can see that immediately we get this feedback where this looks okay, but player with stats does not. So we can come up and say player with stats, and you could just say any. That satisfies it, but what does that get you? It doesn't really help you throughout your code base because now anything can be passed here. You don't get that explicit type checking. So what we want to do is say that this is going to be a player array. Now, let's see, it doesn't seem to be complaining about that because this does satisfy player array. It also has this wins property, so we need to document that too. So really what we need to do is make another type that is player with wins. And that is going to be an intersection type, or a union type, I should say. And we can actually use this and symbol to add properties. So we can say wins, and that will be a number. So now player with wins represents what we're returning here, and we can pass that in right here. Now if we would call this, once again, win count, now it's going to be mad because we're calling this wins here, but our actual type is win count. So let's match this back up. And now let me show you why explicitly making these types is advantageous. The first thing is if we go over to the view.ts where we had originally referenced these stats, you can see that we can now import the derived stats, and we'll import that from the store. So we no longer need this right here. We'll get rid of that entirely, and then we'll add a type annotation, so we're just importing the types. So now stats is derived stats, and then let's also say derived game. This has not been defined yet, but we can export that as derived game. And then we'll import that from the store. Now it's complaining because we're trying to destructure properties off of derived game, which at the moment is just an empty object. Now we know, looking at the store, that what we're returning from the game method is going to be the derived game. And if we look at the return type here, it has an array of moves, so we can import that here. It has a current player, so we can assign it a player, and then a status, which is an object that has, we've actually already defined that too. So that is the game status from our types. So remember, if we go to types.ts, we had the move type already defined, so we just use that there. We had the player type right here, so we defined it here. And then we had the game status right here, which we passed to status. So using these types, we composed a derived game, which is returned from this game getter method. We've explicitly typed that as well. And you can see winner is not correct here because I think we have a mismatch. And I think I pointed this out earlier, but I don't know. Let's see. So explicitly typing this actually exposed, I believe, a little problem here. It says player or null is not assignable to type player. So we're allowing the winner to be equal to null. So if we go to our original types and go to game status, this should actually be player or null. It should not just be player, because if it's null, that means we have a tie game. So that was something that we fixed by being more explicit, which is a good thing, and why you should always explicitly, define your types where appropriate. So now it's not yelling at us for this anymore. We're looking good. Let's see if that broke anything elsewhere. So now we have explicitly typed the render method to pass in a derived game and derived stats. And now the benefit of doing this, if we come back to store and we go back to this game method, or let's say stats. Earlier we were looking at stats and we changed a property on stats. So remember, we previously had no explicit return type. So we just passed win count, just like that, and nothing highlighted here. So if I was a developer and this was a big project and someone else had written this function, it's not very clear to me what the contract of this function is, how it's being used outside or anything like that. So I could come in and change this name to win count and not have any clue that that affected something in another file until I compile it. So if we explicitly say derived stats, now when we change it, it's going to complain because the wins is declared here, but we are calling that win count. So if we put that back to wins, now it's going to be happy, and it gives us the assurance that we didn't break something elsewhere within our code base. So having done these additional typings, let's close things out and run tsc. And everything compiled, and if we come back, our game is working just fine. So that's kind of the benefit, kind of bringing this full circle. Got the benefits of TypeScript. I've demonstrated a lot of this, but really I hope that this video has given you a brief introduction to TypeScript, just giving you some practical examples and kind of a code along to get your feet wet with this, and also to kind of see how we can take a vanilla project and port it over to TypeScript and get that setup done. So if you like this video, give it a like, subscribe to the channel, and I will see you in the next video, which is going to be the same project, but we're going to build it in React. So we're going to take that vanilla JS and make it, into a React app, and then eventually we'll actually do another TypeScript refactor where we'll take that React app and do this same process of typing things. So I'll see you in those next couple videos.